On this RAM 1500 with the 5.7HEMI P0354 points to a problem in the ignition coil for primary control side. In plain terms, the PCM is not seeing the coil 4 signal circuit behave the way it expects. The truck may have a misfire, a rough run, reduced power, or just an illuminated MIL. Possible fault areas can include the fused relay feed to the coil 4 control circuit, the ignition coil, spark plug condition, connector problems, or the PCM driver. The monitor runs continuously with the ignition on, and this code sets when the PCM detects the ignition coil 4 signal circuit current is less than or equal to 0 amps for at least 1-2 seconds. Start with the basic system checks before chasing the coil circuit. Use the scan tool to read codes in all modules, record the codes and captured operating data, and save a scan report. Then erase the codes, turn the ignition off for a minimum of 10 seconds, turn it back on, and operate the vehicle under the conditions that originally set the fault. Read the codes again. If P0354 does not return, treat it as an intermittent problem and do not keep going down the hard fault path. If it does return, continue. Next, look at the codes you recorded. If there are ASD-related faults present, handle those first because they can affect the ignition coil feed and change the direction of this diagnosis. If there are no ASD faults, move on to testing the relay output feed to the coil. Now load test the relay output supply circuit. Disconnect the component harness connector to isolate the 12-volt supply circuit. Connect the positive lead of the load test tool to that 12-volt supply at the connector and connect the negative lead to battery ground or a good chassis ground. Make sure the circuit is actually powered during the test. If it is an ignition feed, the ignition has to be on. If it is relay fed, the relay has to be energized. The load test bulb should be illuminated and bright. A weak or dark bulb means the 12-volt circuit has an open or high resistance condition. If the fuse is open, check the circuit for a short to ground before calling the feed repaired. A proper load test matters here. A 12-volt test light can be used only if it draws enough current. Many high-impedance test lights draw less than 0.1 amps and are not reliable for this. The tool should draw more than approximately 0.75 amps. The load test bulb note calls out about 6 ohms of resistance and approximately 2 amps of current draw. Keep voltage drop in mind too. Even 2 ohms in the circuit can cause a measurement 25% less than battery voltage, and the example total circuit resistance is 8 ohms. If the feed passes the load test, check the coil 4 control circuit operation. Use a 12-volt test light connected to a 12-volt source and probe the coil 4 control circuit at the ignition coil harness connector. Crank the engine for 5 seconds while watching the light. Stay clear of the fan, pulleys, belts, and loose clothing anytime the engine is cranking or running. If the test light blinks brightly, the control circuit is being pulsed, so move to the spark plug inspection. If the test light stays on constantly, go after a short to ground on the control circuit. If the test light stays off constantly, go after an open or high resistance in the control circuit. With a bright blinking control signal, turn the ignition off and remove the spark plug or plugs needed for inspection. Look for cracks, carbon tracking, foreign material, gap size out of specification, and a loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the spark plug, inspect the ignition coil boot for damage and replace the boot if necessary. If none of those spark plug problems are present, the diagnostic path calls for replacing the ignition coil and spark plug, then verifying the repair. If the test light stayed on constantly during the crank test, isolate the ignition coil 4 control circuit and check it for a short to ground. The ignition must be off when checking continuity to ground. Disconnect the ECU and every component connector that contains that circuit, then use the wiring diagram to follow the circuit path. Put the negative DVOM lead on a known good ground, probe the control circuit with the positive lead, and check continuity between the circuit and ground. There should be no continuity. If there is continuity, repair the control circuit for a short to ground, using inline connectors to help narrow down the location. Then verify the repair. If the test light stayed off constantly, isolate the ignition coil 4 control circuit and check it for an open or high resistance. The ignition must be off for continuity testing. Disconnect the ECU and the component connector that contains the circuit. Before measuring the circuit, measure the resistance between the DVOM leads so you know what the meter and leads are adding. Then measure the control circuit from the component connector to the GPEC adapter side. Do not probe the PCM harness connectors. Probing those terminals can damage them and create poor terminal-to-pin contact. If access at the PCM connector is needed, use adapter GPEC Diagnostic 10436. Also remember the GPEC diagnostic adapter can add up to 1.5 ohms of resistance to the circuit. The circuit resistance needs to be below 3.0 ohms. If it is not below 3.0 ohms, repair the circuit for an open or high resistance, then verify the repair. If it is below 3.0 ohms, continue. Before condemning the PCM, determine whether the ignition coil is the reason the PCM coil driver failed. An internally shorted or damaged secondary coil circuit may be involved, so do not replace the PCM before making this check. Remove the ignition coil controlled by the driver that's set P0354 and install that coil in another coil location that did not have a fault against it. Turn the ignition on, erase the codes, then start and run the engine for up to 1 minute. If the engine will not start, crank it 3 times for 10 seconds. Read the codes again. If a correlating fault sets for the new coil location, the path calls for replacing the ignition coil and replacing and programming the PCM, then verifying the repair. If the fault does not follow to the new coil location, continue to connector and terminal checks. If the coil did not carry the fault to another location, inspect the related PCM inline and component connections. Perform any applicable service bulletins. Disconnect the PCM harness connectors, related inline connectors if equipped, and related component connectors. Inspect for poor connector installation, damaged locks, corrosion, water intrusion, weather seal damage, bent terminals, overheated terminals from poor contact, push-back terminals, spread terminals, and poor terminal tension. Repair anything found. Then reconnect every connector fully and make sure the locks are engaged. Erase the codes, operate the vehicle under the same monitor conditions, and read the codes again. If P0354 returns after these checks, the diagnostic path calls for replacing and programming the PCM, then verifying the repair. If it does not return, the wiring or poor connection problem has been repaired. Keep verification separate from the circuit testing. After any repair, verify the repair and confirm the code stays gone before returning the vehicle. The takeaway on P0354 is simple. Prove the feed, prove the coil 4 control circuit response, inspect the plug and coil path, and only move toward PCM replacement after the circuit, coil, and connection checks have led you there. For more diagnostic training, visit stepdiagnostics.com.